Alrighty, let's see what our move is for today. Some math involving lions. Let's look at this problem and guess what move is happening. Alrighty, we're going to look into this problem, but we're not just going to be looking at what move is taking place. We're also going to be looking at how your student may be required to justify their reasoning. As we know, math has changed. Math is not just about finding the correct answer, it's also about your child understanding the mathematical process in various ways. What I'm going to be showing you for this problem is a 4-step model. Now, depending on where you are, what district you're in, what state you're in, your child may be required to have a different format. I've seen 5 steps, I've seen just 3 steps. Again, it just depends on what is expected in your area. For my area, in this portion of Texas that I'm in, students are required to show 4 different ways to show their understanding of the problem. So I'm going to be presenting that with this problem. If we look at it, it says there are 2 lions at the zoo. The weight of the younger lion is 379 pounds. The weight of the older lion is 514 pounds. The question asks, what is the difference in pounds between these 2 weights? So I'm going to set up my 4 parts. Excuse the crookedness of lines. I'm trying as best as I can to model this. So I'm going to set up my 4 parts. The very first box is used to basically show your understanding of what the question is asking. And if we look back at it, it says, what is the difference in pounds between these 2 weights? What I do for problems when thinking about this first box is I have my students change the question into a statement, because that statement is going to help me see, do they really understand what they're supposed to even do for this problem? A lot of times, the problem or the issues that we see with the student's way of thinking comes from how they interpret the question. So I think this first box is very important. So if I had to come up with my own words, I would write in this first box. Now, moving on to the second box. For the second box, we're going to be having the students represent what's going on in the problem using a representation. In this case, since I've talked about the different ways to model math, and one of those ways being strip diagrams, I'm going to be using strip diagrams to model this problem. If we go back into the problem, we see that there are 2 lions. So because there are 2 lions, I'm going to have 2 strip diagrams. How can I figure out the difference between the 2 lions? How do I know which one's which? I see that there is a younger lion, and I see that there is an older lion. So I'm going to go ahead and label the 2 of them. Younger lion. So I'll put YL for younger lion and OL for older lion. If we look back at the problem, it says the younger lion is 379 pounds. I'm going to make a strip that represents those 379 pounds. And just label it. So this is my way of showing that the younger lion is 379 pounds. Okay, moving on to the older lion. It says the older lion is 514 pounds. I want to show that the older lion is heavier. When you're heavier, you weigh more pounds. So I want to make a strip that is bigger or longer than the one of the younger lion. One of the big misconceptions that students have with finding the difference is they want to explain what is different about them. They will tell me, oh, the younger lion weighs less than the older lion, or the older lion weighs more than the younger lion. And yes, that is true. That is how they are different. But in math, to find the actual difference between the two of them, I need to see how much more the older lion weighs than the younger lion to figure out that exact number that represents how much more the older lion is than the younger lion, or how much lighter the younger lion is than the older lion. I am going to have to come up with a number to represent that. How much more does it take to get from this 379 all the way to this 514? Now, if you have not seen this type of representation before, be sure you go back and look at, I have a video on each of the ways to represent the operations. I have one for ways of adding, one for ways of subtracting, one for ways to multiply, and one for ways to divide. But based off of this strip diagram that I've created, I've set up a problem in which I have to compare. Now, yes, we know comparing as greater than, less than, but this type of comparing gives me an exact number. And in order to find that exact number, I have to subtract. So now that I've created my meaning of what the question is asking for, now that I've created my picture, and from that picture, I've determined the move. And if you thought it was subtraction, you're correct. Now I'm going to actually solve. Some students right away may have noticed this word difference. A difference is an answer to a subtraction problem. So even if a student may not have known how to come up with a picture, they can show their reasoning, their thinking, by identifying the vocabulary words that let them know what math is taking place. But again, we're going to use the third box to solve the problem, making sure that when we subtract, the bigger number goes on top. As we know, we start subtracting in the ones place. I have 4 in the ones place, and I need to take away 9. I cannot do that. So I need to regroup. The 110 that I'm borrowing leaves no 10s in the tens place. That 110 becomes 10 ones to make, instead of 4 ones, it's now 14 ones. If I have 14, can I take away 9? Yes, that is 5. So my ones place is done. Moving to the tens place, I have no 10s, but I need to take away 7. I can't do that, so I'm going to have to regroup through the hundreds place. So now instead of 500s, I have 400s. That 100 that I'm taking away or borrowing is going to be added to the tens place. Now, when 100 moves over to the tens place, it becomes 10 10. So now instead of no 10s, I have 10 10s. If I have 10, can I take away 7? Yes. That equals 3. I have 400s and I need to take away 300s. If I have 4, I can take away 3. And when I do, that leaves me with just 1. So now I know the difference in pounds between the lions is 135. Okay, now for the last box. In the last box, I require students to write down what they did using words, so that they can practice modeling their process different ways, because sometimes when they take tests, it doesn't have any numbers to calculate. Sometimes your answer choices may just be words. And if you can't interpret what those words are saying, then you have a hard time connecting it to a move or mathematical process. So I am going to write what I did. It's important for students to know what's being subtracted, because sometimes they may see it written the opposite way. It may say, I subtracted 514 from 379. Very important for students to know when they subtract, they are removing a smaller amount from a bigger amount. So that is why I wrote it this way. I've subtracted 379 from 514. So here it is, all done. I have my meaning of the question in my own words as a statement. I have my representation of the problem using strip diagrams. I use that strip diagram to figure out that this move was subtraction. So if you said subtraction, you were correct. I also show that this is subtraction using the vocabulary word that relates to subtraction, and that's difference. When I subtracted the two numbers, I got a difference of 135. And then in the last box, I told my math process using words. These are just some of the many ways that your child may be expected to show their understanding of math problems. Let me know what you guys think in the comments. Everybody, take care.